Okay, lesson 7.4, evaluating and graphing sine and cosine. This video, I'm just going to go over evaluating sine and cosine, not the graphing component. Okay, so a reference angle is defined as the acute positive angle formed by theta and the x-axis. So a couple things we've talked about in class. Reference angles always refer from the x-axis, right? This is what we called our initial ray. That's where our angles rotate from. What does it mean to be acute? An acute angle is an angle between 0 and 90 degrees, making all our reference angles first quadrant angles, okay? And that'll be very important. So using this fact, the sine of 120 degrees is a second quadrant angle, okay? If I put 120 here, you have to ask yourself, how far is this angle from the x-axis? So that would be equal to the sine of 60 degrees. That's my acute positive angle with the same distance from the x-axis. Okay, sine of 200. So now 200 degrees would be down here. So how far would 200 degrees be from my point of reference on the x-axis? 20 degrees. But think about this. In the third quadrant, the sine function is negative. In the first quadrant, the sine function is positive. So I need to add into here, the sine of 200 degrees would actually be equal to the opposite of the sine of 20 degrees. Didn't really leave myself a whole lot of room. Because this being a quadrant 3 angle, my reference angle is always first quadrant, so all of my trig values are positive, so it would be equal to the opposite of the sine of 20. All right, 310 degrees is here in the fourth quadrant. It's 50 degrees from the x-axis. Okay, our point of reference here is 360 degrees, but using that same line of reasoning, sine of 310 would be equal to the opposite of the sine of 50 degrees. And then cosine of 310, all right, same reference angle because it's 50 degrees from the x-axis. In the first and fourth quadrants, cosine are both positive. Okay, so hopefully you saw what I was doing. For reference angles, your reference angle is your quadrant 1 angle. In quadrant 2, if 180 degrees is our axis of reference, all quadrant 2 angles are 180 degrees minus my angle measure. Quadrant 3, 180 degrees is still my axis of reference, but now my angle measure is going to be bigger than 180. So to get my reference angle, I take my angle measure and subtract 180. In the fourth quadrant, 360 degrees is my axis of reference, so I subtract my given angle measure from 360. Okay, so express each as a reference angle. So try this for yourselves, okay? Use what I did back here. All right, finding the reference angle is the easy one. Just how many degrees away from the x-axis is it? But you have to take into consideration the signs of the trig functions. I'm going to do the two. I'll do these two together. These three. Okay, 90 degrees. When I look at 90 degrees, it's up here on my positive y-axis. This has no reference angle. When theta occurs on one of the coordinate axes, it's its own value. Okay, it doesn't refer back to any other one because depending on where it is on the circle, it'll change the sine, cosine, and tangent. Sine of 5 pi over 4. And I've talked about this in class. Radians. So we'll use alpha. Radians are simple. What's my reference angle? Pi over 4. Why? Because in radians, the reference angle, just look to the denominator. That'll always be the first quadrant angle that you refer back to. Okay, now putting it together though, 5 pi over 4. My numerator, my top number is my bottom number plus 1. therefore putting me in quadrant 3. In quadrant 3, the sine function is negative. So the sine of 5 pi over 4 will be equal to the opposite of the sine of pi over 4. All right, 11 pi over 6 reference angle is just pi over 6. Just keep the same denominator when we're working in radians. My top number is twice my bottom number minus 1, therefore putting me in quadrant 4. In quadrant 4, cosine is also positive. So we would say cosine of 11 pi over 6 is equal to the cosine of pi over 6. Try the degree measures on your own. Okay, now let me sort of jump ahead here. This table is very familiar to you. And not only this table, but this dreaded thing, which many of you probably had to write and rewrite a million times last year in Honors Algebra 2. I'm going to use this video to show you where those values come from. So recall the unit circle. The unit circle is a circle of radius 1. Okay. Theta is my rotation from my positive x-axis up to this point. Okay, we know that that point is x comma y. Now furthermore, if I know that theta, and I know if theta is equal to 45 degrees, then this is a special right triangle. It's a 45, 45, 90. So way back when you studied special right triangles in geometry, I know that the ratio is square root of 2 and square root of 2. My side lengths are the same. And then I know that my radius would be equal to 1. Okay, let me start this over. I just don't want to redo the entire video. A 45, 45, 90. The ratio for the side lengths. The legs are equal. And the hypotenuse is x root 2. So using this ratio, if I know my hypotenuse is equal to 1, okay, because it's the unit circle, so we know the radius is equal to 1. Solving this for x, which would be the sides of my triangle, I divide by square root of 2, I divide by square root of 2. Taking a moment to rationalize this, I get square root of 2 over 2 equals x. What's the importance of that on my triangle? Those are the legs of the triangle formed by a 45-degree rotation on the unit circle. Okay, so how does that affect sine, cosine, and tangent? If this is theta, sine is my opposite side over my hypotenuse. What's my opposite side? Square root of 2 over 2. Now my hypotenuse is just divided by 1. Anything divided by 1. So square root of 2 over 2 is a sine of 45 degrees. Now cosine, I know cosine is my adjacent side over hypotenuse. What's my adjacent side? Well, it's equal to my opposite side, so that's where square root of 2 over 2 comes from. Tangent, opposite side over adjacent side. Okay, well, in the triangle from theta, my opposite and my adjacent side are equivalent, so that's where I get 1 as my tangent of 45. Okay, so let me skip up to our chart here. So we just proved where these numbers in the 45-degree column come from. Okay, they all refer back to special right triangles. All right, so in a 30, 60, 90, now I'm making my rotation 30 degrees. Okay, so in a 30, 60, 90, opposite the 30-degree angle is the short side. Opposite the 60 is short side root 3, and the hypotenuse is 2 times the short side. My hypotenuse is equal to 1, because these are points on the unit circle. So my hypotenuse is equal to 2 times the short side. So 1/2 would be the short side. Okay, short side is the side opposite the 30-degree angle, which makes this short side times square root of 3. Okay, now from our previous lesson, let's look at it another way. I know that the sine is my y value over my radius. Cosine is x coordinate over my radius. Tan is y over x. So if I look at these as the sides of a triangle, remember that that gives me how I move from my origin. X is my horizontal movement, square root of 3 over 2. Y is my vertical movement, so that would be 1/2. Now, because my radius is 1, all of these, well, the denominator for sine and cosine would just be 1, so I'm not going to rewrite that. So what's the sine of 30? The sine of 30 degrees is just my y coordinate at that point. That's where my 1/2 comes from. What's the cosine? It's the x coordinate, so that's where square root of 3 over 2 comes from. Then what's my tangent? My tangent is my y coordinate divided by my x coordinate. So what's happening there? Denominators are equal. I'm left with 1 divided by square root of 3, rationalizing that denominator. And that's where I get that the tangent is square root of 3 over 3. Okay, so again, we just proved where these numbers in this column come from. Now, you don't have to set up special right triangles every single time you evaluate these. Actually, that is not the recommended method. We just don't know if you learned it like this last year, so we want you to see where these numbers come from. Okay, so now let's make theta. Let's make our rotation our 60 degree. Okay, we still have a radius of 1. The ratios still remain though. Short side root 3, 2 times the short side. So if this is my 30 degree angle, I still know that this side length is positive half and this side length is square root of 3 over 2. So then it changes the order of my coordinates. Now my horizontal movement to get to this point was a half. My vertical movement was square root of 3 over 2. So we just changed the x and the y, and that's it changed because the measure of our rotation is different. All right, so sine is my y coordinate over my radius. Radius is just 1. My cosine is my x coordinate over my radius. That's just equal to 1. And my tan is my y coordinate over my x coordinate. 2's cancel, leaving me with square root of 3. And there's our final column for our exact values. Okay, this is something we'll use over and over and over. You need to be able to recall those as needed. Now, 0 and 90 degrees are added on there for you, but if theta is an angle that's on one of the coordinate axes, you're responsible for knowing what those coordinates are. So there's 0, 90, which is pi over 2, 180 degrees, which is pi, and then 270 degrees, which is 3 pi over 2. All right, that'll do it before my computer dies.